Focus on graphing a logarithmic function by wanting to first graph its inverse exponential in that same base. Note, when you graph a logarithmic function, you want to first graph its inverse, which is an exponential function. And then you just flip-flop the ordered pairs, and you'll have your logarithmic function. So here's our first example. Let's graph this exponential function. This exponential function is base 4. So let's just plug a few numbers in. Let's plug in -1, 0, 1, and 2 in for x. So remember, you're evaluating the function for this x. So I say 4 to the -1 power is 1/4. 4 to the 0 power, anything raised to the 0 power is 1. 4 to the 1 power is 4. 4 to the 2 power is 16. So if we graph this on our coordinate plane below, I'll just graph these 3 ordered pairs right here. One, 2, 3, 4. One of our ordered pairs was -1 up 1/4. Next ordered pair is over 0 up 1. That will be our critical point. And then over 1 up 4. Here is our exponential function. It has an asymptote at y equals 0. It has a critical point, which is your x-intercept, of 0, 1. So let's identify those things up here. So our domain will be all real numbers, no restriction on the x values. The range is everything above that horizontal line. Y has to be greater than 0 above that asymptote. The y-intercept is over 0 up 7, your critical point. And then your asymptote is that horizontal line at y equals 0. Now, if we want to graph the inverse function, which is your logarithm of base 4, we just take these ordered pairs over here and we interchange them. So that first ordered pair of -1, 1/4, we're now going to have 1/4, -1, and the next ordered pair will be 1, 0, and then 4, and 1. So we're flip-flopping those ordered pairs. So see what happens when we graph those 3 ordered pairs. So now we are over 1/4, down 1. We're over 1, up 0, and then over 4, up 1. And then I connect the dots here. Here's my logarithmic function of base 4. I have an asymptote now vertically at x equals 0. I have an x-intercept of 1, 0. So now if we answer these questions with domain, range, x-intercept, y-intercept, or y-asymptote, the domain is now going to have a restriction when it is greater than 0 on the x-axis. If we come up back to this vertical asymptote, my graph occurs to the right of that vertical asymptote. My range now is all real numbers. Every number will work for the y. My x-intercept now is my critical point, over 1 up 0. And then my asymptote is vertically at x equals 0.